Advertisers are most certainly tracking the things you click on. Did you know they can also track your mouse movements? And sometimes a few other things? In a world where more privacy-conscious browsers might deny things like third-party cookies, ad tech companies may decide to explore alternative ways of doing targeting. In case you didn't know it, your mouse movement can be transmitted back to the server by JavaScript. That can be useful to user experience engineers in working on web applications, making them more optimized. It can also be used for more nefarious purposes. But at the same time, I've always wondered just how much information is really revealed with my mouse movements. Well, perhaps more than I thought. That's the topic of today's interview.
I'm Leiva, and I'm currently assistant professor of computer science in the University of Luxembourg, in Europe. So I basically work at the intersection of machine learning and human-computer interaction. More concretely, a field which is called computational interaction, where I basically build computational models to try to explain or predict user behavior. So typically, we either adapt or create new machine learning models to account for any behavioral traits about the user, let's say how they pay attention to displays or how they move the mouse or how they use the eye movements, to fixate on something, kind of things.
So if you build a good model of a user, that means it's sort of representative of and predictive of the user's behavior. You're not trying to replace the user. What's the use of the model?
So the main application of user modeling is simulation. Imagine that you need to recruit a representative user sample for measuring whatever. Then you have to spend time designing an experiment, recruiting people, reaching out to them, allocating some budget, for paying them and so on. So instead of recruiting, let's say, 1,000 people for that, then you can recruit maybe 10, run some statistical tests, do some machine learning on data, that you can collect from them. And then you can create a user model that you can try to then to infer some traits or behavioral traits that could be extended to a larger user group. Of course, this is just an example. Typically, you would need a fairly large representative data set if you want to really do some production level machine learning code. But for research purposes, sometimes, even less than 100 users is really more than enough to start drawing conclusions about your user population.
Yeah, it just depends on the effect size you're trying to measure.
Yes, exactly.
With that in mind, can you expand on what some of the behaviors are?
It depends on the study or the kind of analysis that you want to do. For instance, something that I have been doing for more than a decade is to try to infer how people allocate attention on different screens based on how they move the mouse. And why is this interesting? Because then you don't need to really install any webcam, any eye tracker. So you can use the mouse as a proxy of user behavior and see, depending on how they move, how fast they move, how reach out to targets, or how they click on something. So it's not only about the click itself, but how the process, or what happened before the click, what is interesting. And this kind of user models can tell us a lot about, for instance, how the layout or the user interface is designed, and how can we change things, or what happens if we move, one button from the top left corner to the bottom right corner, what kind of behavior this will enable, or if this will facilitate people finding information quicker. These are things that you can measure for free, basically, by running large-scale studies. If you really want to pay attention to how people behave on the web, for instance, then the mouse has been shown to be a good proxy of the eye gaze. Not for every single thing, but for most of the tasks that we do online, the mouse is a very reasonable proxy of user behavior.
Well, I'm glad you made the comparison to eye tracking or gaze measurements. Obviously, we're going to talk mostly about the mouse today, but in terms of making that compare and contrast, for listeners who don't really know much about the scholarship of eye tracking, is that a big thing, and how highly is it regarded? I guess I ask because I think of my own eyes, and it's not really a precision instrument, right? Just because I look at an ad doesn't mean I'm interested. Sometimes I was distracted, or it seems like a very noisy data set. How reliable is eye tracking?
Well, eye tracking is actually one of the earliest measuring instruments to analyze and investigate user behavior. Typically, in human-computer interaction, we are interested in understanding how people pay attention to things or how things are arranged on the screen. And the eye tracking is an essential device in most ACI labs today, and it's not really noisy. Actually, the mouse is way more noisy than the eye. So yeah, I mean, for sure we can go through that later. But I can tell you that by looking at how people experience or how people look at the content and how this is arranged on the screen, this is something that people in marketing and in neuroscience has been using for decades. So I would say that it's pretty standard and widely used, at least in human-computer interaction context. So I guess that not all your audience will be familiar with HCI, with the human-computer interaction literature. But just to let you know that the eye tracking is a measuring device. It's really, really popular in HCI.
So, based on your research and I guess also just things you've read and looked into, do you think that the mouse approach can be a full proxy if for some reason eye tracking was too expensive or just not available for my project, but I do have mouse data? Can I get just the same rich amount of information as data set, or is there like a fidelity loss by looking at only the mouse?
Yeah, well, it depends on the task. Of course, I mean, I cannot give you like a 100% accurate answer about that. But for instance, on web search, how people, how search engines are displaying information. This typical the search engine results page. This page with the 10 purple snippets that you can click on. This is a highly structured information. And in this kind of user interfaces like SERPs, the search engine result pages, the eye tracking and the mouse, according to previous research, has shown to be highly correlated. So how people click on something, people typically will scan the page, then will start. Typically, they have something called the F-shaped pattern. So they start with the top left corner, they do a quick horizontal scan, then go down and do another horizontal scan, and then scroll down. Basically, your mouse will follow. So first, you are going to fixate on some snippets, and then you will click on the one that you believe is the most promising one. So the thing is that all these unconscious process, like how people allocate attention and how they move the mouse to click on the result that they believe is the most promising according to the search needs, this is something that we can easily model, and it's something that provides very, very valuable information, because as you mentioned before, if we can go outside the lab, so for eye tracker study, then we need to put the user in front of the computer and in front of the eye tracking itself. So and then we need to create this user study. We need to allocate some time to recruit people and so on. But with the mouse, we can do very large scale studies. We don't need the eye tracker anymore, in a sense, especially if we know that the page that we are going to investigate or the display that we are going to investigate is following a particular structure that we know, something that we believe is going to be worth of exploration by using the mouse instead of the eye, of course. And in this case, we can go easily from, let's say, 10 or 30 participants, which is kind of a standard set in HCI user studies. We can go from that number to I don't know, 2 orders of magnitude larger. I remember the last study that we ran online, we collected 3,000 participants, about that number. So, we can go from 30 to 3,000.
Well, if I were to participate in an eye tracking study, like you need me in your panel, I'll sign me up. I'll go to some website. I know, like, it's sort of an opt-in. I'm gonna see my camera light turn on, and I'm pretty sure my camera's not on if the light's not on. Although I'm not 100% sure about that. But I know, I'm gonna be filmed and that I'm participating in the eye tracking. When
Yes.
it comes to my mouse, I'm actually super unclear what's even possible technically, like with some little JavaScript callback or something or some WebSocket thing. Can you spy on my mouse today easily?
Yeah, of course. I think you are touching a very sensitive and interesting question. The thing is that nowadays it's super easy to track the mouse movements without the user even noticing that this is happening. It's completely transparent. It's not interfering with your browsing experience. It's happening in the background. You don't notice that, and then the browser will send your activity to the web server without you even noticing. So yes, this is definitely possible. I've been doing that for years. But typically, when I do this, I typically warn the user like, "Hey, we are running this study, so you should know that by entering this site, you agree to certain conditions of the study." This entails some interesting ethical concerns. Like it depends a lot on the responsibility of the webmaster if they really want to warn the user. And in some European countries, for instance, in Germany, there is a law that you must do that. If you don't do it, you can even not only face some fees or some penalties, but also you can go to jail.
A strato is business intelligence that helps you get back to business. As a progressive data leader, you need to be sure that you and your team have the best resources. Having the right tools makes it quicker and easier for you to get the right insights at the right time. Astrato is a modern BI solution brought to you by the experts at Vizlib. Purpose-built for the cloud, Astrato is the next-generation solution for intelligent, accessible data analytics. With Astrato's approachable, no-code solution, you can do more than just empower your team. You'll be able to facilitate quick and easy adoption across your entire organization and ensure that everyone in every department has what they need to answer critical business questions. Your team can enjoy unprecedented opportunities for invaluable collaboration with Astrato's intuitive creative experience. And their integrated write-back functionality enables you to write, edit, and comment on your data without ever leaving your business app. With Live Query, you can explore big data instantly and enjoy greater agility, performance, and security. Best of all, you can try Astrato for free. Visit astrato.io/dataskeptic to sign up. They've got a collection of example workbooks you can try in the cloud or get started with your own data. Visit Astrato, ASTRATO, astrato.io/dataskeptic. So we're all used to those like opt-in consent forms, which are really about cookies, but it wouldn't surprise me if I looked through the 90 pages and found some paragraph that said I was also opting into mouse tracking. Do I have to hit OK for that to start happening, or could my mouse be tracked without me consenting in some way?
Yeah, absolutely. As long as you access a web page, when you enter the URL and you start downloading the page, then from that very beginning, from that moment, your browser can start recording your mouse movements. It's technically possible, it's super easy and it's technically possible. But then at the same time, it's a responsibility of the webmaster to ask for the user consent or to inform, that this is happening.
If I were hypersensitive to privacy, I might be really aghast at this, that, you're tracking my mouse. This feels very invasive. But at the same time, it's only, I would presume, tracking back like in a first party way, that the site I'm on knows where my mouse is on their own page, which, again, maybe that's a privacy concern, but I'm not clear on what's the harm here. What's the most nefarious, villainous circumstance that can happen?
Well, I think that's a very interesting question. So, one of the most recent studies that I did with some colleagues reveals that your mouse movements is telling a lot about you and about your interests. How do you pay attention to different advertisement of the page? What is your age, and even what is your gender? So you are disclosing some potentially private or sensitive information that people might not be willing to disclose, at least not so easily, especially without even noticing.
Those age and gender things I'm having a little bit of trouble reconciling that. So essentially you're saying that based on my age or gender, that's revealed through my mouse movement, that somehow our usage of the mouse is different across those demographic features?
Yes, especially age. Of course, there's a lot of literature. A lot of research literature about motor control and age. So people typically have, for instance, old people typically have more jitter and different movement patterns.
Gotcha.
So there is a huge correlation between age and the kind of trajectories that you, or the path or the tracks that you leave on a website. Gender is not so clear, but still the correlation is there. It's definitely not random. According to the paper that we published some years ago, it's definitely not random. And we also have to say that in that particular paper where we tried to model the gender and the age of the people by looking at how they move their mouse, we didn't spend a lot of effort in the machine learning part. And if we can say a few words about the paper, it's only 5 lines of code that you need to really build a sophisticated deep learning model. With today's deep learning library, it's super easy. So that paper was mostly a call for attention, like, hey, today is super easy to capture mouse movement at large scale. And given that now we have access to very well documented and user-friendly deep learning libraries like Keras, TensorFlow, or PyTorch, then now we should pay attention to this and inform people that they might be profiled without even noticing.
Well, I wonder if we could explore the age prediction. So I'm certain you wouldn't tell me that based on my mouse movements, you would say this person's 41 and male. There has to be some sort of distribution across that. To what degree are my mouse movements predictive?
So, I mean, as long as you collect the right amount of data, this prediction is possible. In the paper that we published some years ago, we framed this mostly like so what you have say is a regression problem for the age and a classification problem for the gender. So it's a regression because you are predicting exactly the age, but typically marketing companies they would like to know your age range. So typically you say, okay, I don't care if it's 41 as long as I know that it's between 40 and 50. I'm happy with that. So in that case, this is another classification task. So it depends. I mean, depends on the study that you want to do. You can frame the classification, the problem as a classification problem or as a regression problem. But yeah, I mean, you're right. You can do this kind of predictions with the right amount of data, and basically you need no more than 5 seconds or between 5 and 10 seconds of mouse movements, and then you're ready to go.
So that maybe, I guess, can predict some demographic features. Could we extend it further and say it could be even individualized? Like, could this become some biometric where my computer says, these don't look like your own mouse movements. We want your password again. Is it at that level of precision?
Yeah, absolutely. Actually, this is one of the earliest applications of mouse tracking as a second factor authentication. Or, I mean, in the research literature, they call this a re authentication method. So once you are logged in, then you can run some inference engine saying, okay, this doesn't look like you. So please enter your password again, like you just pointed out. Yeah.
Could we speak to some of the like key metrics? I don't know if it's precision or recall, or how do you look at the overall accuracy of the models?
So basically, what we did, so we ran a crowdsourcing study with approximately, I don't remember exactly the number, but it's in the order of 3,000 participants. And we asked them to click on the element. I mean, the study was a study about sponsor search. They went to a mock-up of a Google SERP, a search engine results page of Google, that we manually instrumented. So we injected some mouse tracking code, and users were asked to click on the element that answered the query that they had. They were shown a query on the SERP. Let's say the query is purchase Maverick DJ drone, and then you have some results. One of them might be an image, some of them might be typical snippets or carousel, whatever. You can click wherever you want. The task is to get this rich information about the user. And of course, we explain that, okay, you can only participate in this study if you opt in for the following recordings, like IP address, mouse movements, and so on. So people knew that they were recorded. And then after that, when they click on the element on the page that they believe that they satisfy the search needs, then a pop-up or a modal dialog shows up and then ask people, did you notice that there was an advertisement about whatever? And this is the ground truth information that we collect for them. So this was a study about predicting user attention from mouse movements. And it happened that in that particular crowdsourcing study, we also collected demographic information like age and gender. So the first study we did is to predict user attention based on mouse movements. And after that, we say, hey, we have some valuable demographic information, so why don't we predict this information as well? And it turned out that you can predict the age and the gender of the user, at least for segmentation purposes. I think how many classes did we have for the age? For sure, we did a two-class classification, but also I think we did up to six. And for gender, we only did two class because we had only more male and female participant. I think we have only 1% of the people declaring non-binary. So in that case, we tried previous machine learning models, including random forest. I mean, other approaches that were close to what we were trying to replicate. And the machine learning model the deep learning model that we built with 5 lines of code, it was outperforming both classifiers for age and gender by a large margin, I think. So imagine the baseline here is 50% if we're talking about two-class classification of gender. And I think we reach out to 75, which, with 5 lines of code, I think you cannot ask for more. It's super, super interesting, or how accurate you can be with a few lines of code. And for age, it was even larger, the difference. So it's in the paper. I don't remember exactly, but it was about in the order of 80% maybe.
Wow, and you see that even in the cross-validation results. That seems really highly predictive.
And also something that I should mention here is that we only have one sample from each participant. So in principle, I'm telling this because the dataset is public. So in principle, it's not possible to infer the identity of a single individual. So you can do this kind of analysis, like predicting user attention from mouse movements or predicting age, but as a collective, as a population. You cannot really identify uniquely one participant, because if you do the typical machine learning setup, then you need to split your data in training and validation. So there is exactly one unique person in the training or the testing set. So there are no duplications, so it's impossible to infer or to classify an individual.
We're doing our season on ad tech, and a big topic there is how are things going to be charged? Where exactly will someone pay for something? And the general agreement is like a cost per click model, so that you show an ad a certain number of times, and there's an exchange of money from the advertiser to the platform if someone clicks on it, showing it an interest. Although that's not entirely true, there's still some filtering. Like if you click on the same ad twice in the same day, that kind of thing is often only billed once. Or if we identify that your IP address is from like a fraudulent click farm, then I wouldn't necessarily pay for that. There's even some advanced things I've heard about where if they can determine an ad didn't render because it was below the fold and the user didn't scroll down. Well, if you didn't see the ad, why should you pay for that? That seems reasonable too. But now you're talking about attention. What if a publisher shows an ad to someone and they don't even bother to look at it? Do you think it's fair for the advertiser to say, hey, I don't want to have to pay for that person? They weren't paying attention.
Are you following my recent publications?
I've read not everything, but a few. So maybe it's a little bit of a rhetorical question.
But no, because this this question is super. I mean, on point, because I published another paper
Yeah.
where we propose a pay per attention action model. For doing the bidding and for ensuring a more fair process. So currently we have two, let's say, audits in web search: is the pay per click or pay per impression. So either advertiser can say, okay, I'm willing to pay €1 for every click, because this is something, this is organic traffic that I'm going to get from the search engine. Or I can say, okay, I want to pay 1 cent for every impression. I mean, I know if my advertisement is going to be rendered on a website, but I don't care if people will click on it. Then what we propose is, okay, now that we can measure or we can predict with a reasonable level of accuracy your attention based on how you move your mouse, then we can enable a third action model, which is the pay per attention. So you will be charged only if people really pay attention to your advertisement. And this is interesting because some firms or some companies, I don't know, like a high value customer like Rolex or Ferrari, they don't care about clicks. They care about people noticing the advertisement. It will enable a new market in that sense. And we have a paper with a co-author from economics where we show that the pay per attention model is at least no worse than any of the existing audit models. So it's always equal or better than pay-per-click or paper impression.
Well, that's promising then. If when you say equal, is that better for the advertiser, the platform, the user, or is it all of the above?
Typically, is more interesting for the advertiser because it's the people who are putting their money on the ads platform. So typically, you might be charged by unintentional clicks, or you might be charged a lot for a lot of impressions, but the people are not really noticing, or they are not really paying attention to your advertisement, and you are charged anyways if you follow the paper impression model.
Well, a lot of the ad tech world is these giant tech players, Google, the real time bidding platforms, and things like that. Big systems often move slowly. What's the path towards adoption of an idea like pay per attention?
I think everything boils down to having a solid and a reliable mouse tracking JavaScript code. In the same way, for instance, we have the Google Tag Manager, where you can track some events from the user, and this is not very unobtrusive. So it depends, on the granularity that you want to collect. You can get, for instance, one coordinate every time you move the mouse 1 pixel away from the current position, but it's too much. Maybe you need to do some polling strategy, like every second tell me where the mouse cursor is, and then I will do some magic under the hood afterwards. So we need more efficient mouse tracking software in a way.
Well, sometimes I don't know this is always effective, but I like to compare an online experience to an offline experience. And if I go to a store, by walking in the door, I feel like I've inadvertently disclosed my age and gender, or at least my approximate age and pretty much my exact gender. So if my mouse is disclosing that to a website, maybe I'm not aware of it, and that could be a problem. But I guess I don't know that I feel violated. How do you feel about it?
Well, I think it depends on the person. Myself, for instance, I think it's beneficial in a sense that I prefer to have well targeted advertisements. So I don't want, for instance, to imagine I don't want to hear about a pension plan nowadays, not yet. For instance, so if I can get this information or I can disclose this information without having to say so, then I guess that the website can do a good effort in serving me good advertisements. So something that is targeted to me. So personally, I like it, but I can understand that some people don't want to disclose any information, and even without they noticing that this is happening under the hood.
Well, I was trying to think of things that might kind of upset me, and one of the most interesting ones I came up with was drowsiness. That I know this is sort of outside the scope of your work. You didn't look exactly at drowsiness, but if you came back later and told me you studied it and you could use my mouse movements to decide if I was drowsy or not, I would find that plausible. And I also don't particularly want that disclosed to anyone. Is that a fear I might want to have?
Well, I think, of course, I mean, it's something that might happen. As I say, it always depends on the context and the tasks that you really want to enable or disable. So, I mean, it's like a double-edged sword. It could be used. I mean, mouse tracking could be used for policing, but also for social good sometimes.
Well, one option we could have, there are existing ad blocking software. I imagine there could be some sort of plugin that blocked my mouse position from being read, that only the click would be registered. Is that a level of privacy you think consumers should be considering using?
I think, I mean, this is, not directly possible with current JavaScript because every time that you enable JavaScript, then your browser is exposing some APIs that developers can use. So it's very difficult to circumvent that. What you can do, for instance, there are some efforts. For instance, from Google, Google is shipping the Chromium and the Chrome browser, as you know. They are proposing something called the privacy budget, which is like some a mechanism where the developer cannot have access to, let's say, more than 100 events, and in that case, it would be the mouse move event. You cannot read more than 100 times that a mouse movement has happened on the web page, for instance. They call the privacy budget because you have a limited number of events that you can record. And this is one of the initiatives that people are following. So yeah, I mean that's definitely possible, but technically we are not there yet. So it's super easy to track mouse movement at large scale today, and it's very difficult to opt out.
So as you point out, there's that technical barrier. Unless there's some very low-level JavaScript change, it's hard to hide the mouse movements. And also, I think there would be a degradation of service. I think my web experience would be worse if I fully disabled that. But I know early on there was a concern about GPS. So the solution was to like not give the exact GPS, but an approximate one. Could adding a little noise allow some amount of still usefulness, but obscure my exact identity in some way? Is that a viable technique?
Yeah, definitely. This is something that we did in the paper I mentioned about predicting user age and gender. We show in that paper that this is possible, and then we propose a countermeasure. So we propose to add some Gaussian noise to distort the mouse coordinates in a way that your, let's say, your sensitive information like gender and age is no longer available to developers. But I have to say that this has some caveats. I mean, we release a browser extension which is called Mouse Faker. You can find it on GitHub. And the thing is that this browser extension is implemented in JavaScript. So what happens is that when you programmatically distort the mouse movement on the fly, an advanced developer, they know how to filter out those distorted coordinates. So if you really want to make use of this approach, then you should write some software that will trigger the mouse movements or will distort the mouse movement at the operating system level, not at the browser's level.
Is that the next step in privacy, or is that a pedantic thing to do?
Well, I think if people really do care about their privacy, they need to go out of the web browser because the web browser is so powerful that it's really difficult to opt out. So, for instance, if we're talking about this, let's say, obfuscation of mouse movements, that definitely has to be done outside of the browser.
Does that mean potentially at the hardware level? Will I buy a privacy preserving mouse at some point?
No, not necessarily hardware, but the operating system. So, for instance, you can have a background process, and every time you move your mouse, then the background process will distort the coordinate or will trigger an additional coordinate that is, I don't know, like some five or some random Gaussian distribution around your current coordinate. So every time you move your mouse, there is an additional coordinate, but the browser will see two mouse coordinates instead of one. And the thing is that, eventually you will be sending a distorted mouse trajectory to the browser, and the browser will believe that this is a legitimate mouse movement.
So, in general, in terms of consumer privacy protection, I tend to want to be in favor of choice, give the consumer a choice of what should happen. Although there are some cases, and maybe your research falls under this, where you have to get a certain level of education to appreciate even the question you're being asked. I don't know if you agree or not, but I'm curious to get your thoughts on maybe what should default policies look like. Even if we let people go reconfigure everything, we'd like to set it intelligently for the majority who leave the defaults. What's the best defaults out there?
That's a good question. I mean, I don't have a definite answer, but that reminds me to the do not track header that some browser vendors decided to enable by default, and then suddenly nobody was honoring that header. If you remember,
Uh-huh.
so Microsoft, Firefox, and Chrome now they send by default the do not track with the value one. So that means that I don't want to be tracked. So that means that in principle, the web server should honor that header and say, okay, this user is sending me this signal and the user doesn't want to be tracked. But then it's up to the web server to really enable that or not. And then because nowadays every single browser out there is sending the do not track header, then it's no longer interesting or is not, I mean, nobody's paying attention to that header anymore. And for mouse movement or any other privacy related settings, there should be something not really equivalent, but something that is easy for the user to modify. But at the same time, that we should provide some sensible defaults. I agree with you in that sense. But it's unclear, if people, sitting on the server side, will honor that values or not.
Well, in my mind, your paper is a proof of concept in two ways. First, it's a proof that you can infer these demographic details to a certain degree from mouse data. and then also a proof that there's a defense technique that adding a little noise can make that a harder thing to do. So we know now that this is doable. Do you have any proof or even maybe intuition or hypothesis that this is being done in practice? Are mouse movements used to track users online today in this way?
No, of course. I mean, every single search engine like Bing or Google, they are tracking your mouse movements to some degree. Maybe they're not with a extremely fine grained level of detail, but they know not only where you click, but how you click, or what is the sequence of elements that you have visited, the elements that you have hovered. So there is a lot of fine grained information that happen on the client side that is impossible to collect by only looking at the typical server logs. So a server log typically is one line with your IP address and the URL that you have visited. Of course, you can do a lot of things with this kind of information, but once you go to the client side, you go to the browser, and you have access to the JavaScript APIs, then you can get a really large amount of valuable information about the user. So yes, I mean, most of the big players in industry are tracking your mouse to some degree.
What can you tell me a little bit about what's going on next in your line of research?
So the thing is, particularly, I'm interested now in getting more physiological signals. So not only the mouse, but also your brain activity, which is even noisier, according to some preliminary tests that I've been running with my team recently. So my goal would be to get as much information as possible from the user in order to modify the interfaces that we are interacting with. So, for instance, if we can tell if the user is stressed or if the user is happy, the cognitive state of the user, ultimately is this kind of information that we would like to make use of in HCI. So this is what I'm doing now. So trying to get more information, physiological information, heart rate, brain activity, eye movements, mouse movements, so on.
Well, I consider myself to be a little bit of an earlier adopter in that sort of regard. I'm ready to lay down a little cash on some fancy hardware. What might I be able to buy 5 years out that would help improve my interface with my computer?
Yeah, actually, we are running a European project which is about creating symbiotic applications where both the system and the user will co-evolve together. So the user will send to the interface all the cognitive information on mouse movements, eye movements, brain signals, anything that we can measure from the user, and the interface will adapt itself based on the cognitive state and the current situation of the user. Maybe you are in a hurry trying to find some information, so the interface will sense this state and will remove the clutter and will give you the answer to the question that you have, for instance. Or if you really want to slow down and get a very accurate answer, then in that case you might tolerate more clutter or more information to see at the same time on the screen. So this is the kind of thing that I'm doing now with the project that I just mentioned.
Exciting stuff. For listeners who want to learn more and follow up, where can they go online?
So currently, the project just started last week, actually, and it's a very ambitious European project. It's called Symbiotic InfoVis. So we plan to adapt information visualization systems based on the idea that I just said. So if the system can sense what is the cognitive state of the user, and also they can know what the user intends to do, and if the user is a novice or an expert, then the system can render the information visualization in a way that the user will be more comfortable with. For instance, imagine a novice user will tolerate, let's say, very few components on the screen. They don't want clutter and they want very simple visualization like a bar chart. But an expert might tolerate more modules, more information, and instead of a bar chart, you can represent the same information with a line chart, for instance, with some tooltips and any other interactive elements. So then the expert will be shown that information.
Well, very cool, exciting stuff. I look forward to following up as progress is made.
Yeah, if you want to Google that up, it's symbioticinfobiz.eu, and there you have all. I mean, this is a preliminary website, but you will, if you follow the blog, we will be posting every month our latest advancements.
Awesome. We'll have links in the show notes to follow up. Luis, thank you so much for taking the time to come on and share your work.
Thank you for having me. It was a pleasure.
That concludes this episode of Data Skeptic Ad Tech. Here's a taste of the next interview.
Striking that balance between maintaining someone's privacy while also having enough data in an anonymized fashion, I think is absolutely critical to delivering relevant messaging, relevant advertising messaging to a consumer.
That's next time on Data Skeptic Ad Tech.